are. The best part of the day, right, is the awards. So my name is Kathy Barabee. I'm the Worcester Public Schools Science and Engineering Liaison. I would like to thank you all for coming and participating in this science fair today. I want to introduce a few people. My co-chair working with the judges today is Chris Racine from Burncoat High School. Thank you, Chris. And our coordinator of all the teacher volunteers is Danielle Morrow from Forest Grove Middle School. So there are a few key people we're just going to take a minute to thank. First of all, the Ecotarium. They host this event for us at like next to no charge. And many of you have had a chance to see exhibits here and bring your families and watch planetarium show. So we really want to give a big round of applause and thank the Ecotarium for supporting our event. We had 54 judges coming from area colleges, industry, EMC, we had a veterinarian, we have some high school students who judged. Many students who are in the advanced placement science classes or AP Science came to judge projects today. We had student teachers from Anna Maria College. We had a lot of people come and judge. So we want to thank the judges. I also want to thank parents and guardians and those adult supporters who are helping kids do science fair projects. We know it's not easy, right? Supporting our students. In addition, the teachers who helped these students do projects. So if there are middle and high school teachers in the room, please just kind of wave your hand. We want to give you all a big thanks. A big thanks to the teachers. And then my favorite thanks in my job is to you, the students, our future scientists and engineers. You know, you guys are what keeps the teachers and the administrators coming back to do our job because we're so excited to see this group of new scientists and engineers moving on to college or high school AP courses. Or maybe one of you will be my veterinarian one day and take care of my dog. So that's what I'm really hoping for. Okay? The teacher committee, we had a lot of Worcester Public Schools teachers helping tonight, so if your teacher was one of those people, make sure to thank them. I also think it's important to thank our school committee and our Worcester Public Schools administration, Dr. Rodriguez, the quadrant managers. That team supports us in all of these events. So why do we do this event? As I mentioned, it's so that we have our future scientists and engineers to acknowledge the great work of our Worcester Public Schools students, 7th, 8th, 9th, 10th grade students, 11th grade. You guys are getting ready for high school and college. We do it to support your interest in endeavors. Two of our judges tonight were former students sitting in these seats. And what a thrill that was for me when they emailed and said, hey, can I be a judge? I used to do science fair project. In fact, I won in my year. And to have them come back as judges, that's very, very rewarding for us. Two of our Worcester Public Schools teachers have also had a NASA experience. They're from Worcester East Middle School, so they had an opportunity to work with NASA space team and actually get a stratosphere space flight. So even our Worcester Public Schools teachers are out there doing great things in science. So the big news is the awards. What I'm going to do is call the middle school awards first, which would be 7th and 8th grade. When I call your project number for an award, I'm going to ask you to stop at the middle of the room, and Danielle is going to hand you your trophy. And then I want you to come down here, and parents, guardians, classmates, and friends, that's your chance to take some pictures. And then we'll send you back to your seat, okay? So let me just... These are elementary projects. Okay, we had quite a few projects that were so close. That's why it took us long to sort the scores. Some of your projects were separated by 0.5, half a point separated some winners. So these projects were really, really good. All right, so if we start with a Judges Award of Merit in middle school, Judges Award of Merit in middle school. Let me get my middle school column. I have a Judges Award of Merit. There are two projects that deserve Judges Award of Merit. Project number 97 from Sullivan Middle. This is Joni Hoxa, Strings Attached.
My hypothesis was the smaller the wavelength, the faster the string will vibrate. Therefore, the string will produce a higher velocity. So velocity is basically speed in a general direction, and wavelength is the amount of time it takes for a single cycle of, well, a sound wave. You would pluck the open E string, and using the tuner, find the frequency. You would also record the data. Then you would fret the low E string on the first fret, and then find the frequency readout and record it. Then you would repeat step 4 for frets 2 through 12, and then you would record the data as usual. And then using the formula, velocity equals frequency times wavelength, you would find the velocity of the data recorded. I recorded everything here, and I turned everything from here and brought it into the graph. So as you see, the string length is on the x-axis, the independent variable axis, and the velocity is on the dependent axis. So the data definitely seemed a little bit off, and that might be due to human error. I thought that it was mainly because I might have measured it wrong, or it might just be something that happens because there was always something around this area that was, I guess, off.
Chris, why don't you stand up here, and this is going to be the official handshaker. And how about Project 95, also from Sullivan Middle, Abigail McDermott. And her project is the effect of light color on photosynthesis.
My science fair project is on the effect of photosynthesis on an Elodia plant. I would put an Elodia plant, which is a water plant, in a jar, and I would fill it with water, and then I put bromothymol blue in there, and I put it under a lamp on different colored lamps for an hour, and then the bromothymol blue would change color depending on the acidity of the mixture. So if the acidity of the mixture is high, that means that there's more CO2 in the mixture, and that means that less photosynthesis is happening. Where if the acidity was lower, then we can infer that there's more photosynthesis happening because there's less CO2. My hypothesis was that if the plant was given red or blue light, then more photosynthesis would happen. Because of the pigments in the plant, the pigment in an Elodia plant is called chlorophyll, and that pigment absorbs blue and red light best. So therefore, my hypothesis was that more photosynthesis would happen when the plant is under either a blue or a red grow light. So as I did my experiment, I started to notice that more photosynthesis was happening when the plant was under the red light. And that didn't really surprise me, but what did surprise me was not as much photosynthesis was occurring while it was under the blue light. So basically my hypothesis was half supported by my results.
So, dear fan club, take some quick pictures if you want. All right, okay, so you guys can return to your seats. Thank you. At the end, we'll let them come back up. How's that sound? Okay. In 4th place for middle school, making sure there's not a tie here, 4th place for middle school is project number 122 from Forest Grove Middle School, Travis Campbell.
The marble mega coaster is a roller coaster for marbles made out of foam pipe insulation. And I have a demonstration here where you take them, I have a big and small marble, and I took turns putting them in and having them go down the slope and to see if it'll make the loop. I predicted that the marble would have to travel 36 inches off the ground for it to go through the loop, but it actually didn't have to. The small one only had to be 18 inches off the ground, and the big one had to be 22 inches off the ground for it to work. I really feel confident that it worked, even though my hypothesis was totally off. The small marble will go first on 57 inches at the highest point. It works.
And his project was called Marble Mega Coaster. Thank you. So his fan club, take a picture. All right. Okay, thank you, Travis. So we can also give you time to take pictures afterwards, definitely. Have the kids come up here with their trophies. All right, in third place at middle school, it looks like we have a tie, two-way tie. Third place, I'm calling out first project number 98 from Forest Grove, Lee Procaro, Falling Down.
My project is Falling Down, and I investigate which type of bridge has the greatest weight-bearing capacity. I built 3-mile bridges, the arch, beam bridge, and suspension bridge, and tested how much weight each one could hold. I have my experiment set up, and I built the bridges, and then I made a setup and put water in a bucket and tested how much water each bridge could hold. So I put this instrument on top of the bridge, and then I kept pouring water and putting water bottles into a bucket, and then waiting for the bridge to fall, and I recorded how much weight the bridge held. So the beam bridge, which is right here, weighed 31 pounds after its destruction, and the arch bridge held 42 pounds, and the suspension bridge held only 6.5. In the real world, the suspension bridge held the most weight, but in my experiment it held the least. I think this because it was in compression, the deck was in compression, and most of the weight fell onto the deck. And the arch bridge held the most weight because it's all under compression and the weight was evenly distributed along the bridge, so that's why it held the most weight.
Congratulations, Lee. So your fan club's good. All right, and also third place, a third place tie, exactly the same score from Sullivan Middle School. Bahan No.
For my science project, I tested to see which diaper brand held the most water and like if the expensive ones that you were paying more money for held more. So I took 5 brands of diapers, Up and Up, Parents' Choice, Huggies, Loves, and Pampers, and I added increments of 15 milliliters of salt water. I let the 15 milliliters absorb, and then I added another 15 milliliters until it wouldn't absorb anymore and there was a puddle. So after calculating my averages, I found out that Up and Up held the most water, which was the cheapest diaper, and Pampers, Pampers, which was the most expensive one, didn't hold as much as a diaper that was half the price. So parents really were paying too much for diapers. Up and Up diapers were about 13 to 14 cents for each diaper, when Pampers was 34 cents for each diaper. So you could be saving half the amount of money and having your diaper hold more water. Parents' Choice was the worst. It didn't hold, it held almost half as much as Up and Up. And then that was very low compared to the rest of the diapers. Loves held much more than Parents' Choice, and then it just went slightly up for Huggies, Pampers, and then Up and Up. I wanted to do this because I have 6 baby cousins that are in diapers, and we're not rich, so I wanted to see if I could help my aunt save money.
Her project was called Are You Paying Too Much for Diapers? All right, second place in middle school, there's one project for second place, and that comes from Forest Grove Middle School, Project 113, Jacob Williams.
My project was how to build a crystal radio receiver. My purpose was to find out how well I can test the radio waves near my house. What I did was I built a simple crystal radio, and it took a long time to build it. Once I built it, I brought it outside, connected it to an antenna and a ground rod. Once I connected it to the antenna and the ground rod, I hooked it up to the amplifier, which turns the signals into the words so that I can understand them and I can hear them. Once I did that, I sat there for a good 40 minutes or so, listening to the radio and seeing what stations I could pick up. I picked up WCRN, Boston's talk radio, and WEEI, sports radio. And both of these radios were really fun to listen to because I was really happy when the project worked.
In the end, my project was extremely successful and my results were extraordinary in my opinion. 2 fun facts you might want to know is on Christmas Eve in 1906, the first ever radio message was sent not in Morse code. And the golden age of radios was from the 1920s to the 1940s, which that was when radios were really progressing and becoming smaller and smaller so they could fit into different things like cars, and at one point they could fit in your pocket, which I thought was pretty interesting.
Nice job, lady. All right. Now, a two-way tie for first place. Both projects come from Sullivan Middle School. Projects number 118 and 120. Why don't you both come up together? 118 is Cindy Nguyen, and 120 is Catherine Poppenshock.
For my science fair project, I was testing out how the wing length of an elastic launch glider could affect its airtime. So when I researched about it, I learned that the more surface area an object has, the more force of lift that can be acted upon it. So I thought that since an 8-inch glider has more surface area than a 6-inch glider, that it will stay in the air the longest. So for the independent variables, the variable that I was changing was the wing length of a glider, and the thing that affected by the wing length of glider was the airtime. So I measured that in seconds. So these gliders are all made out of balsa wood, and I used hot glue just to piece them together. So when I collected the data, it showed that it was true, and as I increased the wing length of a glider, the glider also stayed in the air the longest. The 6-inch glider average stayed for 5.27 seconds. The 7-inch glider stayed in the air for an average of 5.59 seconds, and the 8-inch glider stayed in the air for 6.16 seconds. So even though the differences between the average were only a few tenths of a second, it still showed that as I increased the wing length, the time in the air also increases too. Overall, my hypothesis was true, and it was proved that as I increased the area of a glider, the air time also increased.
For my project, I made a grabber, and so basically I got the idea for this because when I was little, I used to imagine making a flower picker sort of thing, and that turned into a grabber because then it can be used for more than just flower picking. My goal was that it would be able to pick up things of a certain size or weight, and then it actually was able to do that because originally I thought it wouldn't be able to pick up things, but it would be able to close and open, but now it's actually able to pick up things. And so with the engineering design process, I had to design it several times before I went and actually got the materials to build this. And when I was building it, I had to make it at least 3 times because each time it didn't work. It's called the interchangeable grabber because I made a different attachment for it, so it's unique compared to other grabbers that you see at stores. So I have the grabber attachment and then the scissor attachment, which the scissor attachment didn't work this time. So if I were to redesign the project, I would have the scissor attachment attached from the back of the scissors instead of the middle where it wouldn't close all the way.
Catherine, did I pronounce your name right? Thank you. All right, so Cindy's project was called Elastic Launch Glider, and Catherine's was the Interchangeable Grabber. Nice job, ladies. Thank you. All right, as we move on to the high school, we're going to start with the Judges Award of Merit. There were some really good projects. Judges were commenting on the sophistication of some of the high school projects. So nice job, high school students, okay? All right, so High School. Judges Award of Merit. We have 2 Judges Award of Merit. The first Judges Award of Merit is project number 109, Worcester Technical High School. Angel, Shanette, and Taya Casey.
Our project is You're Safe, but Is the Water? The purpose of the experiment is to determine the water quality and see if it's safe for a lot of species around it. For the water quality, we have tested the pH, nitrate, phosphate, dissolved oxygen, and alkalinity. And by what our results were, we can determine if the ecosystem are safe for the surrounding and also if it would affect the aquatic species.
Throughout our testing, we found that the pond and stream behind our school are healthy. However, more testing will be needed because it is winter, so you don't have certain aspects of the environment playing into raising our testing results. However, for the snow that we did test, for December 28th, 2015, we found that it was acidic by 5.5, 26% more acidic than the national average of 5.6. For the snow sample from January 12th, 2015, it had a pH of 5. With this, we worry about episodic acidification. This refers to when buffering capacity is low and the natural buffering capacity is low in lakes and streams and soils. It acidifies those lakes and streams, and when it acidifies the soil, it releases aluminum, which is highly toxic. But in order to get a more definite findings, we have to do more testing throughout multiple seasons in order to find out the true health of our rain and of our ecosystems. So far, the pond and stream do seem safe. However, the rain is acidic, which is very bad for our environment. Now, it really depends on how many times it's usually acidic when it rains. And in order to find that, we have to do more testing.
Everything needs water to survive. So if we want a future, we need to protect our waters and streams while we see it. In the future, if it's gone, we can't replace it. So we have to fix it right away.
Oh, hold on. So let me talk to you after and make sure I have the correct title for your project so I can report that, okay? Thank you. All right, the second Judges Award is also Worcester Tech. Project number 90, Julian Danek and Stephanie Heligado and Heidi O'Connor. Is that correct?
We were told that if you practiced on the virtual welder and you had never welded in shop, that you could go out into reality, which would be the shop world in our case, and be able to weld perfectly. Turned out that from the welds, as you can see, it didn't work.
The virtual welder doesn't account for all the variables that you would experience in the real world. One that's commonly noted is for heat, the sparks, the restrictions, all the heaviness of the PPE that needs to be worn. As for the helmet, the gloves, the leathers, the toe tappers, the beanies. On occasions, you use respirators too due to all the fumes. There's just too many variables that aren't accounted for when it comes to virtually welding. The difference between the weight of the equipment is so great that it can't prepare you for what's going to come if you go into the actual shop. This torch weighs like the same amount as a feather, whereas for an actual MIG torch, it weighs like a brick. And the same for the helmet. The helmet has the little eyes that lets you see into the virtual world and all these cords going around everywhere that restrict your movement. Whereas for the helmet, it's a lot lighter. In the actual shop, you have to wear 100% cotton. Cotton is really essential when it comes to welding because if you wear any sort of polyester, it will melt on your skin. And that's not a fun experience. The difference is too great that one can't learn how to weld on here and be able to weld in reality.
There's just too many differences, and in conclusion, we believe that the virtual welder is great for tips. It's great for teaching you terminology such as arc length and travel speed and stuff, which we didn't understand when our teachers would talk about it before we got this machine, and now that we've used it, we understand that. But when it comes to teaching you how to actually weld, I don't think it's a tool that you could learn on and then be able to weld fine in the real world.
And this project was called Virtual Welding versus Real Life Welding. So obviously in the weld shop. All right. Move over, make room for him. How bad did I mess up your names? A little bit? Very bad? Okay, well, we're going to take a moment. Don't leave. All right, so correct the pronunciation. Start with Julian.
Oh, his name is Jack.
Jack?
Jack Ryan.
Okay.
And for me, it's Stephanie Delgado.
Stephanie Delgado.
My name was correct.
And your name, Heidi O'Connor. All right. So let me make sure to correct your name. Okay, thank you. Oh, man. So I'm thinking my copy paste maybe didn't work so well this time. Okay. In third place, so that, oh, I'm sorry, fourth place. So a fourth place award, Worcester Technical High School, Project 108, Hogvo and Casey Cologne, nail polish at a price.
Our project is on nail polish remover. We're trying to find out if it's bad or is it good for you. We paint the nail polish on a wash glass and test various types of nail polish removers to see which one work the best. We use 3 types of nail polish removers. One is non-acetone, one is regular one, which is acetone, and another one is body pure.
After we took off the nail polish, we used the infrared spectroscopy, which helps us analyze the types of chemicals in nail polish removers. And then we also used the nuclear magnetic resonance, which analyzes the quantity of acetone and ethyl acetate in nail polish remover samples. We found out that acetone, which is the regular nail polish, it has about 76 milligrams per liter, and in 4 hours, if you inhale that, it's deadly. For ethyl acetate, which would be the non-acetone, it'll be 45,000 milligrams per liter in 3 hours, so which is worse. And then we have body pure, which means that one has no acetone or ethyl acetate. That one's the one that's not volatile, which means it's not airborne. If you breathe it in, you're perfectly fine. And it's not toxic.
And the efficiency of the nail polish removers. The non-acetone one, it's literally hard to scrub. The regular one left some nail polish. And the body pure one, it came out fast and clean. And therefore, the body pure ones is the one that's safe and also the cleanest one.
So for this project, we were trying to find out which nail polish remover would be the healthiest choice and the best choice in, let's say, in a medical facility and a nail salon, because that's usually where they use it.
As a caregiver, I want to give my patient, my residents, and even my family the best choices there are, so they can have better health and safety.
So we chose to do this project because it's something that we're probably going to see a lot in the medical field, especially with all the side effects of it being exposed to this, which is cancer, miscarriages, abnormal fetal development, and breathing and lung disorders, which is basically what we're training to take care of.
Nice job. All right. Okay, hold on. I think Miss Coughlin's taking a picture there for you. Okay. In third place in high school, so that was Judges Award fourth. In third place, Project 99 from Doherty High School, Patrick Wallace, The Wonders of H2O2, hydrogen peroxide.
My project was about discovering how the environment would affect hydrogen peroxide. And I discovered that the temperature did affect the hydrogen peroxide, but the sunlight didn't do anything. I have an O2 gas sensor right here, connected to a TI Inspire, and the O2 gas sensor senses the release of oxygen from the hydrogen peroxide, because when you have hydrogen peroxide and catalase, then the hydrogen peroxide decomposes into water and oxygen, and I could sense the oxygen release.
Congratulations, Patrick. So turn just for a second. So everybody can take a picture. You got your fan club? Yeah, they took a picture of you? Okay. All right, thank you. Thank you, Patrick. All right, second place. Second place is second place, project number 105 from Worcester Technical High School. Somi Morales, Xavier Sotomayor, and Tyler Da Silva.
What we have here are 4 different pipes that we use in the plumbing industry for residential and commercial. So what we did was we put distilled water in each of the piping, and we introduced E. coli to each one. And after a certain amount of days, we were able to take a sampling and do the readings on each of those to see which material killed off the bacteria more.
E. coli is a bacteria which is commonly found in the lower intestines of your body, and E. coli is harmful. It can make you sick, but the worst kind can actually cause death, which you do not want in your pipes.
After we got the samples from Xavier in plumbing and pipe fitting, we were able to take the samples down to my shop, which is biotechnology, and read those for how many cells per square centimeter were on the pipes. And that allowed us to find the readings and how much cells were alive, so that way we could determine which pipe was the healthiest for drinking water, and then later deduce which one was most cost effective for how you wanted to drink.
Copper came out with the best results. It killed off the bacteria the fastest and it provided us with the cleanest water.
And how bad did I mess up your names? Pretty bad? Pretty good? Okay. Okay. Sawami Morales, I'm sorry. You are smiling and you're taking your photo. All right, and first place in high school, Worcester Technical High School, project number 88, Melanie Acosta, Tatiana Beckford, and Jolyn Hampton.
Our overall purpose for this project is to determine rather which water source in Worcester can support microorganisms, and from our data we can explain the health effects on humans.
We made our hypothesis based on the visual appearance of the water source and the area surrounding it. The 3 lakes that we believed would have the best conditions to support and encourage and maintain microbial growth was Bell Pond, Indian Pond, and Quinsigamond Lake. We did numerous tests to see which one had. One test we did was the pH.
So the pH is what measured the acidity and the alkalinity of solutions, and so from the pH scale 4.8 and 9.2 is the best optimal conditions for microbial growth, and based on all our water samples, they all fall under that range.
The next part of our project was we took the water samples and we put them on what we call LB plates. LB plates provide the bacteria with a suitable food source, so that when we put them at different temperatures, if there are bacteria in the water, they have a good environment to grow at. We did 37 degrees because that's what bacteria typically like to grow at, and we did room temperature so that it's closer to the actual water sample that the bacteria was living in.
That's really great. I think that's really right.
Based on our analysis chart, Institute Park Lake and Indian Pond had the best optimal condition for microbial growth. And based on our hypothesis, only one of the ponds that we picked for actually had what we predicted.
Because this was such a difficult project, we did not just do it ourselves. We had a lot of help from our shop, biotechnology. We had help from 2 friends of ours, Madison Mercedes and Venus Nuwan, and from our teacher, Dr. Andrea Pereira. They were big helps in organizing the data and performing the experiments, and we'd like to thank them very much for that.
All right, is there a third student? All right.
No, Melanie is not on it.
Okay, so Tatiana Beckford and Jolyn Hampton?
Yeah.
All right, and what's the title of your project?
Can Worcester water support microbial growth?
That's what I have. Okay, great. Congratulations. Wait for your photo. Wait for your photo, guys. Okay.
Here we go.
And that was first place. So with those awards handed out, I want to thank everyone for coming, for working on science fair projects. I want to make sure that teachers and parents and guardians have a chance to take pictures of your students with their awards. If you want to do it here or somewhere out on the floor, make sure you have that in your archive. You can also look for this video to show on our local cable channel television. As you can see, it's being taped right now for production there. Thank you very much, and congratulations to the winners.
I want to introduce myself. My name is Jeff Glick, and I am the district science coach for the elementary schools. And I want to welcome you. Always good to have like a fan group here. I also want to introduce Joe Cox from the Ecotarium, the president of the Ecotarium. And Joe is going to say a few words.
Thank you, Jeff. Welcome, everyone. So glad you got to spend some time with us here at the Ecotarium today. The Science Fair is probably my favorite day all year long of everything that we do here at the Ecotarium. And I think the reason is every year I'm so impressed by the quality of the projects that we have. I had a chance a little bit earlier today to walk around and see some of the projects, and there's budding hydrologists in the room, and engineers and scientists of all kinds. In the room we might have the next Elon Musk, who invented SpaceX and is making a huge amount of money selling Tesla cars. There might be the next Richard Branson, who's going to take us into space on Virgin Galactic. There might be a name that you may not recognize, Hedy Lamarr, who was an incredible actress in 1942 who paved the way for Wi-Fi. Anyone here like Wi-Fi and using cell phones? Yeah, 1942 was when she first came up with that idea. Marie Curie, who a lot of you've heard of, paved the way for research in radioactivity. And they all started somewhere. And that somewhere, for all of you who started on your science fair projects, starts with that hypothesis. It's like, what if? So please keep asking yourself, what if? Keep following science, because we need the next scientists to change the world and make the place a better place. So thank you, and thank you to Worcester Public Schools.
Thanks, Joe. I want to start out with a bunch of thank yous. I want to thank Joe and the Ecotarium. This is such a great event for us to have here with all of the science and being able to enjoy the exhibits. The Ecotarium does this for us basically for free, and we are so proud to be here. This is an occasion that takes quite a bit of planning, and the Ecotarium is here to support us all the way through the process. I also want to thank the judges. We have judges that were here today from area high schools, from corporations like EMC, from some of the colleges, some former Worcester Public School folks. So we had a lot of judges, and I want to thank them for their help. We also had lots of teacher volunteers that were selling pizza and working as security guards upstairs, and we appreciate those efforts as well, scoring, and it's just lots of little pieces. I want to thank the parents. You guys put up with a lot of budding scientists, as Joe was saying. Science is a messy area, and we appreciate the efforts that you put forth. I also want to thank the students for being enthusiastic, for being here and participating in this great event. As Joe said, you are our budding scientists. You're going to be the ones that are being the engineers, people creating our next cures for diseases, and we need you to be keeping your nose to the science grindstone, so to speak. I want to thank the school committee for their help in this process, and also the Worcester Public Schools Central Administration Building, folks down there. There are lots and lots of projects, as you saw, and unfortunately, not everyone leaves with a trophy. But the real winning is the participation, to be here, to be able to show your knowledge on a topic. And there were projects up there that people had to explain to me, and I think that's really a great thing to be able to say. just a real quick thing that I heard. One is that some of our judges tonight were former students in this same auditorium. So they were people who participated when they were either in elementary school or in high school, and now they're judging for us. So I thought that was a really kind of fun thing to hear. Another thing I heard one student say is, now I know my path in life. And I think that was really kind of a fun statement to hear. And who knows what will come of having participated in this event. I do want to invite folks down for their trophies in a minute. And what I'd like you to do is when you come down, if you would just come on down, and then we're going to turn around so you get your picture in the video. If you are one of the people who get a trophy and you weren't interviewed when you were upstairs, what I want to do is have your teacher contact Channel 11, and they'll come to your school and interview you there with your project. So if you're one of the winning people, don't throw your project away. You're going to need it. Okay? Also, when you leave this evening, don't forget your project upstairs. And that's happened before in the past as well. All right. Lastly, before we get to the awards, I did put some things on the table that you can take a look at as you leave. Some things for the Ecotarium camp, some things for Ecotarium birthday parties, and some other information about some of the events at the Ecotarium. So please feel free to grab that before you leave too. And something, I like the eagle, that's up in the gift shop. So there's my shameless plug for the Ecotarium. All right, so let's see if I can get this going. So there were times I want to make sure I get everybody called that gets an award. And what I will do is read the project number, the school, the student's name, and the project name. And excuse my pronunciation on some of the names. Okay, so our first person to get an award this evening is the Judges Award of Merit. Goes to project number 23, Hurd Street School, Taylor. How can you mix oil and gas to make a lava lamp? My hypothesis was that when you add Alka-Seltzer to the bottle, that it will sink to the bottom and it will start to create a gas and it will start to rise upwards. And the colored dye, when you drop that in, it will come up with it. My conclusion was that I was correct on my hypothesis, and the reaction is when you mix water, oil, and Alka-Seltzer, it will create a lava lamp. Thank you. Our next winner is fourth place. It's project number 6 from Chandler Magnet. The student is Ko and Yasmin, and it's airplanes. So come on down.
This is our project, How Far Will It Fly? Our question is, which airplane design will fly the farthest?
Our purpose is to test how far each airplane flies and learn more about drags. Our hypothesis is we think the small plane will fly the farthest because of its size and design. This is our first draft. This is the plane without added drag, and this is our second draft with the drags. Our material is 3 sheets of paper, metric ruler, 1 roll of masking tape, tape measure, scissor, and lab notebooks.
During our project, when we jotted down our results, what we noticed was, number 1, small on flight 1 needed 10 more inches to fly as far as medium did on flight 5. Step number 2, medium flew the farthest. Number 3, small flew like so-so. Number 4, large flew the closest of them all. And number 5, the plane flew the farthest without added drag.
In our conclusion, our hypothesis was that we thought the small plane would fly the farthest because of its size and design. During our experiment, we observed that our hypothesis was wrong. This made us think that it does depend on its size. Our data design proved that medium went the farthest and it was the best design. We learned that it doesn't depend on the design, it depends on sizes.
Our third place this year is also a tie. The first winner is project number 65, West Tatnick. It's Maxim and Sound versus Brain. Our other third place winner is project number 22 from Gates Lane. That's Helena. Which region of the United States has the healthiest dogs?
My hypothesis was that the dogs in the Northeast would be healthier than the dogs in the Southwest. I learned that the dogs in the Southwest are actually healthier than the dogs in the Northeast, and the dogs in the Northeast have a higher variety of diseases than I thought they would. I started out with only these 2 states, but after I made the graph, I saw that I needed more data. I chose Massachusetts because it's the state I live in, and I chose Utah because Utah is far away from Massachusetts, and Utah is much different, very different.
Second place, also a tie. First one is number 69 from West Tatnick. It's Oliver. Now you see it, now you don't.
My hypothesis was that cola would disintegrate limestone the quickest, and I thought this because cola was what is very fizzy. The 4 liquids I used were cola, white vinegar, distilled water, and lime juice. White vinegar ended up actually disintegrating the most limestone, and lime juice disintegrated the second most, which was 1. White vinegar disintegrated 6 grams, lime juice disintegrated 1 gram, and the other 2 disintegrated 0 grams. I think the cola went flat and became a basic, and I think that the distilled water, since it didn't have, once the minerals became in it, once minerals go into the water, it became a basic as well.
Our second place winner is project number 4 from Chandler Magnet, Willow Mummification.
hypothesis, well, I had two materials, baking soda and salt, and my hypothesis was that when I put the hot dogs in, I thought that the baking soda would do a better job of mummifying the hot dogs, but it turned out that the salt actually was better. For my procedure, I measured the weight, length, and circumference of each hot dog, and after a week, I put them in a container with the correct material, and after a week, I took them out and measured the length, the circumference, and weight again. And then I repeated the process, but I didn't repeat it for a third time. I concluded that the salt was a way better mummifier. And the baking soda hot dog actually turned green, so I had to throw it away, but the salt one is here.
And our first place winner is going to be project number 40 from May Street, Albee, and Jersey. The effect of video games on children's blood pressure. Congratulations.
Our project is on how video games affect children's blood pressure and health.
Our hypothesis was that video games raise blood pressure, your heartbeat, and your breathing rate.
Our materials that we used were a board, well, two boards, a blood pressure monitor, skewer, pencil, notebook, everything. Colored printing.
We bought a blood monitor and measured our heartbeat and our blood pressure. And we would put them on a violent game for 10 minutes, and then we'd measure before and then after. And we had a skewer, I think it's called, and we'd poke them 10 times during the game.
And before and after the game 10 times. And we would by using the blood pressure monitor, we would take the monitor, we would put it on our left hand over our wrist, tight on the heart, like near the heart. And then we would then press the button, and it would show us the systolic, high blood pressure, diastolic, low blood pressure, and the pulse. And for breathing rate, we would set a timer to 1 minute and just breathe normally and count in our head how many times we would breathe before and after the video game. And if you're wondering what video game we used the game Halo Wars because we wanted to use a violent video game, but not too violent. So we ended up with the result that it did in fact raise the blood pressure, breathing rate, and heart rate, but we also found out that it would also people would get used to playing the video game, and it would almost even out after a while, the results. And some of us actually went down instead of up. Mine once or twice actually went down because I'm actually used to playing video games once in a while, so mine actually went down once in a while. And we found that younger children who aren't used to playing video games went up a dramatic amount. So we came to the conclusion that by playing intense video games, it raises systolic, diastolic, like I told you, high and low blood pressure, pulse, breathing rate, and pain tolerance, and that the more intense video games raise it the most.
And that's it for our 2016 Science Fair. We look forward to you guys, since you're in 5th grade, being back with us again next year for the 6th grade. So thank you very much for your participation. Grab a brochure and then head out that way. Thank you. This
Good evening, everyone. Thank you so much for spending some time with us here at the Ecotarium, and thank you to all of our scientists who are participating in the science fair. You know, the science fair is probably one of my favorite days of all of the amazing things that we do here at the Ecotarium. And I had a chance to go around and look at some of the projects a little bit earlier, and it's always so fascinating because here in one room we've got future engineers, we've got future hydrologists, we've got future botanists. You know, everyone is starting somewhere, right? So you're all starting on a career towards science. And if you think about scientists who are out there who've done amazing things for humankind, we've got people like Marie Curie, who was on the forefront of investigating radioactivity. We've got this incredible actress, Hedy Lamarr, who back in 1942 was one of the people who invented what would become Wi-Fi. Anyone ever here need Wi-Fi? Cell phones? 1942 was when she first came up with that technology. Incredible people like Mae Jemison, who was an astronaut who was out there in space exploring. Elon Musk, who's making a fortune selling electric cars and blasting rockets up into space. Richard Branson, who's going to take a lot of us and potentially some of you here in the room out exploring space on his Virgin Galactic spaceships. And Neil deGrasse Tyson, who's a TV celebrity and an astrophysicist. And you know what they all have in common? They all started somewhere. They all started as scientists with a hypothesis. What's the question? Why are we doing this? Why do I want to know? What do I want to know? So thank you all for being inquisitive, for asking questions, and good luck tonight. Thank you.
Thank you, Joe. One of the things I was thinking about when Joe was talking is that really, we all know science is everything around us. And that's why I love science, is because it explains the world. It explains everything we see. The other thing, when he mentioned Elon Musk, I was just seeing that he's now in the process of trying to create a transporter that will take you from San Francisco to LA in 30 minutes, which now takes hours and hours. And he's in the process of coming up with this very, very elaborate system of transportation, which I thought was really, really neat. I'm going to start out by giving some thank yous to a bunch of people. First of all, I want to thank the Ecotarium, who is so generous to host this event. This is actually our 7th annual Worcester Public Schools Science and Engineering Fair. And they've all been held here, and each year gets better and better. The exhibits are so much fun to explore and to play around with. And I don't know if you got a chance to kill some of those people with the electricity. Awesome. But thank you for the Ecotarium. They are so generous with their staff and their time. And this does take some time to set up. We've been here for the past couple of days with lots and lots of help. So thank you to Joe and the Ecotarium staff for sure. I also want to thank the judges, and we had judges here today from all kinds of different places. We had high school students, AP high school students. We had college students. We had students that work for different corporations in the area. We had judges from colleges. We had judges who were former Worcester Public School employees. So we had people from all over. I want to thank them as well. I want to thank our science fair helpers or supporters, and that includes the teachers in the classrooms who have spent hours and hours working on projects with students, as well as parents who were at home doing the same. We know that these projects aren't something that just spring up. There's a lot of work that goes into them, and I know that some of the projects people have been working on for literally months. So I want to thank our supporters for that. We also this year had a teacher committee, which was great. So the teachers worked and helped us out, made things work so much smoother, I think, and I want to thank those folks. Everything from pizza salespeople to our scorers to people who are just doing, we call it security. So thank you for that. Also thanks to the school committee and for the Worcester Public Schools administration for 20 Irving Street and the folks downtown. Couple of other things. This year, one of the things I was noting as I was walking around is there were a couple of judges that mentioned that they had been involved in the fair when they were students, when they were in high school. So these are folks that were in high school, now they're in college, they're judging, and so it was really nice to see that they've evolved that way. I also have to tell this story again. I told it to the 5th graders too, but I heard one student say, "Now I know my path in life." So because of their involvement in the projects fair, they feel like they figured something out. I'm still figuring out my path in life, but that's okay. So someone said that. Also noteworthy is we had one school that had their winners were all girls, and it's great to see the girls involved in science. It's not something that has to be just the boys. It should absolutely be as many girls as boys. So. The other story that was related to us, or another story that was related to us, was that some of the people sitting side by side with students from other schools actually have made arrangements to get together socially. So it's not just the whole academic component, but the social component. I think that's really impressive. I also want to note that there was one student that was late to the fair because he was involved in taking an exam at Worcester State College. Made it to the fair, got changed into a suit, and was up there just a few minutes after the time that the judging started. So that was pretty cool too. We have always had great projects, and that is no different this year. We have some projects that are ties, and that's always great too. So when you come down, what you'll do is I'll shake your hand, you'll grab your trophy, take a minute, look at the camera so that we can have your picture in the video. So that when you're called, come on down. If you were not interviewed upstairs and you are a winner, an award winner, what we want to do is have your teacher contact Channel 11. And then Channel 11 will come to your school. They'll interview you there in front of your project. So make sure that if you are an award winner, you have your project available to bring it back to school. For everyone, if you'd make sure you take your project this evening, because we do need to clean up tonight. So please make sure that when you leave with your project. Anything else? Yes. On the table, I also have some Ecotarium information. So if you're interested in becoming a member of the museum, there's information for that. Birthday party information, summer camp information. So that's all right there. Please feel free to grab a brochure. If we run out, there are other brochures upstairs that we can get for you too. Anything I left out? I think we're good. Okay. So I'm going to... Yes, thank you. That's right. So what I'm going to start out with is the Judges Award of Merit. And we have a tie for the Judges Award of Merit. I'm going to try my best to say people's names correctly. The first Judges Award of Merit goes to project number 70. It's Nelson Place School, 6th grade, and Lily. So Lily, come on down.
Pegram, and my school is Nelson Place. My project is Blown Away, and my hypothesis was the triangle will make the best sail because of that's what sailboats use. The star will be the worst because all the holes, the spaces between them, will let the air pass by. My conclusion is that the hexagon did the best, the pentagon did the second best, the square did the third best, and the triangle did the fourth best. The star did the worst. So I was right that the star did the worst.
This was actually a three-way tie. Our second Judges Award of Merit is project number 43. It's McGrath. It's Kiera. What removes oil from feathers the best?
Hi, I'm Kiera Durrell, and I'm in 6th grade, and I go to Francis J. McGrath Elementary. And my question was, what cleaning solution cleans bird feathers in an oil spill the best? And I found out that a mixture of Dawn and cooking oil cleans the bird feathers from an oil spill the best.
Our third Judges Award of Merit goes to project number 21 from Flag Street. It's Shmuel, how to maximize the altitude of a water rocket.
My hypothesis is a combination of 550 milliliters of water, a Coke bottle, and 3 fins. Fin 1, cone 2, and fin material 4 will be the most efficient combination. The way a water rocket is launched in the air is by pumping air into the launch pad. The air is then enters the pad and builds up as pressure. As you keep pumping, more pressure builds up in the bottle. When the bottle is pumped all the way, it releases from the launch pad. This pressure then pushes the water out of the rocket, which propels the rocket up into the air. The fins cause the rocket to spin, allowing the rocket to reach higher altitude and remain stabilized. When the rocket reaches its highest altitude, it tumbles, and the cone falls off the top of the rocket, causing the parachute to be released out.
Our fourth place winner tonight is project number 53 from Norback School. It's Lauren. How do you make stationary objects move?
My name is Lauren. I go to Norback and I'm in 6th grade, and my project was how to make stationary objects move. I was trying to find out when I switch on and off the switch, would it work? Would the tail and wings move? And then I found out that it worked. When I switch on and off the switch, it works.
Our third place is looks like another three-way tie. We have our first one is project number 71 from Midland Street, Kaylana. The project is called What Makes a Good Conductor? And her teacher's right here.
My experiment was I had to go around my house finding materials that I think would be really good for my conducting experiment. So if it is a good conductor, then the nose light up on these bugs, and if it's an insulator, then the nose wouldn't light up. So my hypothesis was that if some metals would make a good conductor, then it will allow electrical current to flow through the metal objects. So how this experiment works is I take a metal object and I attach it to these clamps on the bug. And now if it's a good conductor, the nose will light up. And if it's not a good conductor, like a magnet, then the nose would not light up. So the difference between these two is that these are two C batteries and these are two D batteries. So in order for it to work, I needed two batteries, because if I were only to use one, it wouldn't work, because each battery has 1.5 voltage in them. So when I read the flashlight packages, it needed 3 AAA batteries. So if I were to use 2 C batteries and 2 D batteries for this, it would equal to 4 volts, which is equal to what I needed for the light emitting diodes to work. So the reason why I looked at the flashlight package is because I got these little light bulbs from it. They're light emitting diodes. I just use those because that's the only kind of lights that I could find. I got them at a hardware store, and I built the bugs by 2 different kinds of batteries and pipe cleaners as the legs. These clamps that most people use for cars and other batteries to be the testing. Then I used a straw so I can stick the light emitting diodes in there to look like a nose. And then I used some wires and some wire strippers. I stripped one end of a battery, and then I connected it to the bottom of the battery, and then I took the other side of the batteries after I taped these two, and then I put it on the top, connecting the other top of the wire that I stripped to the light emitting diode, and then connecting that to the battery. In conclusion, in all the objects that I tested, metal did make the best conductor, so therefore my hypothesis was proven true. Now, for next time, I would like to do this experiment again. It was really, really interesting and fun to learn all these facts about Ohm's law and resistance and current and all the facts about electricity. Although I would add a voltmeter so I can compare conductors and see if which metal would make the best. But online in my research, this is a copper washer. Copper, they said, is the best metal conductor.
Also, a third place winner is project number 32. It's from Hurd Street. Andy, how far can my balloon-powered car go? Congratulations, Andy. That's great.
My hypothesis was that my balloon-powered car can go at least 3 yards. So I had 3 attempts. So I blew into my car 5 times on the first attempt. It went 154 inches. So my second attempt was 178 inches, which corrected my hypothesis. My third attempt was 7 breaths, which got up to 198 inches, which still corrected my hypothesis. So I chose this project because I like wind and cars, so I mixed it together and I get this. Yeah, it's really fun. It may look like a toy, but it still has stuff that relates to science, like potential energy and kinetic energy. Potential energy is when energy is stored in an object. Like when you blow in the balloon and then stop it from leaking out air. That's called potential energy. But when you let it go, it converts into kinetic energy, which means any object that's moves, which has the energy stored in. Like when you let it go, it turns into kinetic energy and then it stops. The faster the object, the more kinetic energy it has. The slower the object, the less kinetic energy. In conclusion, I learned not only balloons are fun to play with, but it also can be related to science, which has energy stored in the balloons.
Our next winner is project number 27. It's Flag Street. Nicole, does the battery brand affect the velocity of a robot?
My hypothesis was that I think what will happen is that the brand will affect the speed, and the brand Duracell will have the best quality out of the 3 batteries. Well, my conclusion was that the first part of my hypothesis was wrong because the brand does not affect the speed of the robots, but the second part was correct because Duracell has the highest quality.
Our second place winner is project number 49 from Sullivan Goddard Scholars. It's Glory and it's Magnet Wizard. No, I'm sorry. Where are we? Testing elasticity. Is that right? Testing elasticity. Sorry about that,
Glory. Glory in 6th grade from Sullivan Middle School. My project is called Stretching It, Testing Effects of Temperature on Elasticity. My hypothesis was that in hotter temperatures, an elastic band would stretch farther. In lower temperatures, an elastic band wouldn't stretch as much as it would in hotter temperatures. But after testing it, I came to a conclusion that my hypothesis was incorrect. And that my data showed that in hotter temperatures, an elastic band would contract, and in colder temperatures, an elastic band would expand easier.
Thank you.
And our first place is also a tie. First place is going to go to project number 36 from Jacob Hyatt. Shelley, which fruit contains the most DNA?
So my hypothesis is it depends if the fruit has more cells because that is where the DNA is contained. I believe bananas have the most DNA because we share 50% of our DNA with bananas. I was testing which fruit contains the most DNA, so I was extracting DNA from fruit. And to do this, I needed 3 ounces each of a banana, kiwi, and strawberry, a coffee filter to filter the fruit and so the liquids would go down, 2 to 3 pinches of salt, Esperol alcohol that is cold because cold alcohol actually helps protect the DNA from being damaged. Then I used 2 teaspoons of clear shampoo because it actually breaks down the cells so that the chromosomes and the nucleus will be shown. And the chromosomes is where the DNA is contained. Then I use an eyedropper to pick up the fluid, 3 plastic cups, test tubes, water, and a scale, and 3 small bowls. For my procedure, first I mix salt, shampoo, and 4 teaspoons of water, tap water, trying not to create bubbles. Then in a separate bowl, as you can see, I mashed fruit and a little water into the fruit pulp. Then I took 4 teaspoons of my fruit concoction into the shampoo salt mixture, and I gently mixed it until the mixture became a homogeneous solution, and I wasn't trying to make too many bubbles. And now that I had my fruit and shampoo mixture, I placed the filter above the cup, and then I poured the mixture into it. And then I filtered it until there was about 2 teaspoons, which equals 1 tablespoon. And lastly, I poured the alcohol into the test tube, 4 teaspoons of it into the test tube. And then I took the dropper and picked up my 1 tablespoon of the juice and poured it into the test tube. And automatically, as you can see, the bubbles are starting to rise. They started rising up in the test tube, showing that meaning that the DNA is coming up. In conclusions, I just honestly thought this project was a huge success. I mean, I couldn't ask for anything more. My hypothesis was actually true. Bananas do have more DNA than kiwi and strawberry.
And last but not least is project number 25, flag. Madeline, what kind of memory do you have? That's a good one for me to try out. Congratulations. That's good.
So my hypothesis is that most people tested my experiment would have a better visual memory than an auditory memory. I thought this because humans have a whole piece of our brain devoted to our vision, whereas our most of our auditory memory is in our temporal lobe. So. I learned that there are different parts of your brain that are made for certain things, like your senses. So I really learned that your visual sense is overpowering to your auditory sense.
And again, I want to thank you all for your participation. I look forward to seeing you all here next year for middle school. So I hope you're back in 7th grade doing the science fair again. Thank you. And we're going to exit out